the structural modeling, and the entire program is written, code is written here in the VHDL language. We will see one by one. Okay, first of all, library IEEE is selected here. Okay, so if I am selecting the IEEE library, most of the input output data types are designed or already implemented here, and VHDL is IEEE standardized language. So we will use IEEE dot standard logic library 1164.all. Okay, the semicolon is used to terminate the statements. Okay, if you want to comment for any line, you can comment it by using two simple dash, and whatever your comment, you can write it down in front of these two dash. So I am writing here selecting library selected. So library selected, this is my comment for this row. Okay, now entity FA is. Now here the syntax is entity is the syntax, FA is the entity name. We have already seen the rules for the entity name. It can be combination of letters, alphanumericals, or to separate alphabets or numericals you can use the underscores, but you cannot use two underscores simultaneously or consecutively. So this is the syntax. Entity is, in between that you write the entity name. So I will again comment here, I'll write here entity declaration. Just like number of rows, you can write down the commenting part. Whatever the comment you want, put just super two dash and write down the comment. Now entity will define the interface, IO interface. Now IO interface means entity will only define the inputs and output ports. So let us define. So port, first what we have is A, B, C, which is nothing but colon. Colon part is there in between the ABC and the data type, of which data type they are. So ABC are the variables or the input ports having data type input type standard logic. Okay, it is defined in the IEEE library, that's why we are using the IEEE library here. And S and C are the output type of data, output standard logic. As you see here, S and C are mentioned at the last. Okay, so we are going to, what we are doing here is the structural modeling. So we are caring about the structure and the interconnections between the components and not the data flow. So only interconnections are required. So what I am considering here, that I am taking part into consideration A, B, C and S and C. What is going to inside that, what is happening inside, that I will be designing in the architectural part, structural part. Okay, so final input and final inputs are shown. A, B, C are the inputs and the final outputs are S and C, that is output standard logic. And these are the only requirements, IO interface in the entity. So it is declared. So I will end the entity. So this is the syntax. You write end and the entity name as it is, followed by the semicolon. Now entity part is declared, entity part is complete here. Now what we will do, we will describe the architectural part. So what is the syntax? Syntax is you have to write down architecture, which kind of architecture it is. So it is a structural type of, so I will write down structure of FA. You can write down the entire part. So this is nothing but the name of the structural modeling. So architecture, structural modeling of full adder. So entity name you have to write here, structure of EA, which entity you are defining, structure for which entity, that the entity name you have to mention here, that is nothing but FA. Sorry, I said EA. FA is full adder, entity I have defined full adder, FA is. Okay, in the next line, signals associated with this entity or the architecture. The signals are, signals means now we are going inside the box. Entity we have declared the outside of the box, inputs and outputs. Now we'll go inside. Inside how many signals are there? Signal S1 is there, C1 and C2. These are nothing but the carry generated from the half adder 1 and half adder 2. And these signals are standard logic signals. Now input or output not mentioned because they are connecting lines, they are signal lines. We are not bothering whether it is having 0 value or 0 value. So it's a standard logic value signals. Okay, now these signals are associated with some components. Now there might be possible that multiple components are there, but if you'll see, there is only one component which is used two times, half adder, half adder. So we will declare the component for only one half adder. If suppose you are using 3 NAND gates, 2 OR gates, you will define component NAND only once, component OR only once. Okay, so two half adders are used. So for two half adders, I will define the component half adder HA for only one time, which is having ports A comma B, which is input standard logic port, and the output ports sum and carry, that is the final sum and final carry, that is the output standard logic.